Okay, so this is the higher paper question 7, the last question on the paper, and therefore probably the most difficult. A teacher wanted her class to investigate the reactivity of the halogens. Each group of students was given the following chemicals. So we've got chlorine water, bromine water, iodine water, lithium iodide, lithium chloride, and lithium bromide. Explain how the students would use these chemicals to show the order of reactivity of the halogens. So what we need to know to answer this question is that chlorine is the most reactive of these three halogens, and that all the halogens would much prefer to be part of a compound than as pure halogens, because when they're part of a compound, they've gained the full outer shell, which is what all these elements would like. So perhaps the best way to address this question would be to set up a table to show the different combinations that you would react. Okay, so if we turn this into a small table, and across the top, we're going to label this. So we'll have the compounds. These are going to react with chlorine water, bromine water, and iodine water. Going down here, we could have lithium chloride, lithium bromide, and lithium iodide. We turn this into a table. Okay, so the combinations where we've got the halogen and the halide, there's no need to comment, there's no need to do those combinations because nothing would happen. Okay, so those are non-reactions. And then if we look across each row, if we put bromine water into lithium chloride, there will be no reaction because the bromine is less reactive than the chloride and therefore cannot displace it, cannot change the color of the solution because of the bromine will remain as bromine water. If we add iodine to lithium chloride, then the same would happen, no reaction. Iodine is the least reactive of the three halogens and therefore won't displace either of them, or either of the other ones. And with that in mind, if we add iodine water to lithium bromide, we get no reaction because iodine isn't reactive enough to displace bromide. However, looking at the other side of the this divide, if we add chlorine water to lithium bromide, chlorine water is pale yellow, bromine is an orangey brown color. Okay, so we get pale yellow changes to orangey brown, and that's due to the displacement of the bromine. Okay, so bromine comes out of solution. Sorry, the bromide becomes bromine, and therefore we get the orangey brown color. If you add chlorine to lithium iodide, then again we get the pale yellow goes to a deeper red color, and that's due to the presence of iodine. Okay, so that's there is a reaction there. Then if we add a bromine to lithium iodide, then we get the orangey brown of the bromine changes to the deeper red, the iodide. Iodine, rather. Okay, so more reactive halogens displace less reactive halides. Okay, so these are the halogens at the top, and these are the halides down the side. So wherever you've got a halogen that is more reactive than a halide, then you do get a displacement reaction. But if the opposite is true, you don't get a displacement reaction. Okay, explain in terms of their electronic structures the trend in reactivity of the halogens. Okay, so the more complex the electronic structure. So by that I mean from chlorine towards iodine, down to iodine, the less reactive cause more shells between the outer electrons, or outer shell rather, outer shell and nucleus reduces the ability of the nucleus to attract electrons. Because when halogens react, they do so by gaining an extra electron to fill their outer shell, and the further away that outer shell is from the nucleus, then the more difficult that becomes. Okay, that's the end of question 7.